Hello, welcome to this lesson on tabular representation of data. This is ITE 1812, Mathematics for IT. We will first look at the learning outcomes of this lesson. So by the end of this lesson, you should be able to generate frequency distributions tables from data, and also generate cumulative frequency distribution from data, and also compute relative frequency and percentage frequency. So we will take one by one and see how we do that. First, getting introduced about tabularization of data. So this basically means presenting the data in a summarized form. So it could be for numeric data as well as non-numeric data. So for numeric data, we have several methods of tabular representation. For example, frequency tables, relative frequency tables, histograms, frequency polygons, ogives, and so on. And also for non-numeric data, we can introduce frequency tables, bar charts, and pie charts. So some of these concepts and tabular representations may be familiar for you, but some of these may not. So in this lesson, we will focus on frequency tables, relative frequency tables, and cumulative frequency tables, mainly targeting numeric data. So first, let's have a look at frequency tables. So this takes into consideration the frequency of a particular data value. So that means the number of times the data value occurs. So this is one of the kinds of tabular representation. It can be applied to numeric as well as non-numeric data. So we use this tally of the values in marking and generating the frequency table. So there are three steps we can identify in producing this frequency table. So step one is first come up with a table with 3 columns, and then you have to write down all the data points in the ascending order. Step 2 would be taking the tally. For each value, what is the number of occurrences? And step 3, based on those tallies, you derive the frequency for each value. We will take an example to describe this. So this is example 13.1. So you have a set of values. So these are marks awarded in an assignment secured by students in statistics. So we have many values like 6, 7, 5, 7, 7, 8, a series of values like that. So we are asked to present these values in a frequency table. So how do we do this? We go for those 3-step process. So step 1 is arranging this set of values in an ascending order based on the marks. So when you do that for these set of values, you have 4, 5, 6, 7, 8, 9, and 10 in the ascending order. So in the first column of the table, you have the marks ordered ascendingly. So step 2 is going for the tally. Then you take each value and you mark the tally on the second column of the table according to the number of occurrences. For example, the first value is 6, and you mark 1 stroke under the tally column. And the second value is 7, and then you also mark a stroke or a line in the tally column, and so on. Like this, you continue doing for all the values in the series given. When you do that, you have a tally column, what you can see in the table below, table at the bottom. So based on that, you can have the corresponding frequency. So for example, for the value 4, the frequency is 2, value 5, frequency is 2 once again, value 6, frequency is 4, 7 is 5, and so on. You can come up with the frequencies for all the values. So what you see at the bottom in the table, what we call the frequency representation of data, frequency table. Right, so that was the simple example of coming up with the frequency tables. Now we go on for go one further more, and we try now to generate frequency tables with class intervals. So this is helpful, especially when the data values are spread out. So there will be too many rows, lots of rows. So in this case, we have to group the data into class intervals. Otherwise, we cannot handle these set of data because there is too many values. So the frequency in this case, frequency of a group is the number of data values that fall into the range specified by that group or the class. So ideally, we should have between 5 and 10 rows in a frequency table. Otherwise, it could be too many. So how do you get the number of classes k as the smallest integer such that 2 to the power k should be greater than or equal to n? What is this n? It is the sample size. So we will soon take an example. So for example, let's take n, that is the sample size, to be 108. Then when you take 2 to the power k should be greater than 108, k becomes 7. So we need the k to define the class width. So how do we find the class width? It should be approximately equal to range over k. So what is the range? It is defined as the largest value in the data set minus the smallest value in the data set. So we take one more example later on this. Before doing that, we will introduce what is meant by class limits, boundaries, and intervals. So what do you mean by class limits? These are the smallest and largest observations in each class. So identified as lower limit and upper limit. So this is related to a certain group of values or a class of values. And then we should also identify class boundaries. So these are the midpoints between the upper class limit of a class and the lower class limit of the next class in the sequence. So when we take an example, we will understand this better. So you can identify upper and lower class boundaries. And then also what we mean by class intervals, the difference between the upper and lower class boundaries of any class. So we take an example to understand the concepts better. So consider the following table. You have set of classes and the corresponding frequency. So you have first class from 200 to 299, frequency is 12. Second class is 300 to 399, frequency is 19, and so on. So you are asked some questions from this data set. First question is, what are the lower and upper class limits for the second class? Part B is determine the class boundaries of the second class. Part C is determine the class intervals for the first class. Okay, let's take one by one from this data set and try to answer. So part A is about second class. So you can see that it is from 300 to 399 and the frequency is 19. So the lower class limit is 300 and the upper class limit is 399. That's pretty straightforward. So part B is about second class also. So we are asked to determine the boundaries. So there's a lower boundary, lower class boundary, as well as upper class boundary. So how do we get the lower class boundary? It is the midpoint between 299 and 300. So that is 299.5. And similarly, how do we get the upper class boundary? it is taken as the midpoint between 399 and 400. So that is 399.5. So that's how you get the lower and upper class boundaries for the second class. Next question is about the first class, that is 200 to 299. So we are asked to determine the class interval. So how do we get the class interval? We take upper class boundary minus lower class boundary. So similarly to the method in part B, we can determine the upper class boundary as 299.5 and the lower class boundary to be 199.5 for the first class. So how do you get the class interval? You minus from 299.5, you minus 199.5, you get that as 100. So the class interval for the first class becomes 100. So this example gives you the clarifications of the concepts of class limits, class boundaries, as well as class intervals. Take one more example here. The number of calls from motorists per day for roadside service was recorded for the month of December 2003. So these are the results. So you are given a set of values here. So you are required to set up a frequency table for these data values. So let's see how we approach this. So first, we need to find the width of the classes. So if you remember, you need to go for this relationship. 2K should be greater than N, all right? So here, we also need the range. To calculate the range, we need the smallest and the largest value. So the smallest value in this data set, you would figure that out as 28, and the largest value to be 217. So N is equal to 31, which is the number of data points in this data set. And then you can take the relationship 2 to the power K should be greater than N, which is 31. And K is determined as 5. So how do you get the range? You take the largest value and minus the smallest value. The range is 189. Now, how to calculate the class width? You divide range by K. So range you have 189 and K value was obtained to be 5 and you get 37.5. So approximately rounded value is 38. So class width you have to select as 38. So now, since we have the class width, you can come up with the class intervals. And then in the next step, you can come up with the tally and the frequency as well. So you construct a table with 3 columns. And then in the first column, you include the class interval. So from 0 to 37, so that is our class, the calculated class width, which was 37. And then from 38 to 75, 76 to 113, and so on. So equally, classes with equal widths. So similarly, as the previous example, now you can come up with the tallies. So you take each value from the data set and you try to see which class interval it belongs to. For example, take the first value, 28, it belongs to the class number 1. And you have next 122, it belongs to class number 4. And then you have 217, it belongs to class number 6 in this case. So on. Continuing like this, you will get all the tallies for the class intervals. And once you get the tallies, you will have the frequencies. So for the class number 1, you have frequency as 1. Class number 2, it is 4. Class number 3, it is 13. Class number 4, it is 8, and so on. So you get the frequencies for the class intervals. Right. So we move on to another concept, which is relative frequency. So relative frequencies are used in comparison to populations. So far we have seen examples of just one population, but when you have two or more different populations, then you have to use this relative frequency interpretation. So in the two populations, sample sizes can be different. Then you cannot directly compare them. That's why you come up with this concept of relative frequency. So as the sample sizes are different, it would not be fair or sensible to compare the frequencies falling into different categories. Therefore, we have to consider the relative frequencies. How is it calculated? It is calculated as frequency divided by total number of observations. So using the relative frequencies calculated, we can draw the relative frequencies histogram and relative frequency polygon. We will see how we do that. So here in this data set, you are given marks obtained by 116 male students and 292 female students in a statistics course. So you are required to draw the relative frequency histogram and frequency polygon separately for male and female students. So approaching the solution, so you first have to calculate the relative frequencies for males and females separately. So you are given the class ranges, different classes, starting from 0 to 20, 20 to 40, 40 to 60, and so on. So corresponding frequency for males and females are also provided. So how do you calculate the relative frequency? You divide the frequency by the total number of occurrences. So 15 over 116 gives you 0.129 relative frequency. Similarly, for other classes, you do that division and you arrive at the relative frequency. Similarly, for the other data set from females, you calculate the relative frequencies for each class. 54 divided by 292 gives you 0.185 and so on. So then when you have these relative frequency values, you can first come up with the relative frequency histogram. So how do you do that? We have discussed that in a previous class. So you draw the histogram based on the different classes, 0 to 20, 20 to 40, and on the y-axis, you have the relative frequencies. For the class number 1, the value is 0.129, class number 2, the value is 0.276, and so on. So for all the classes, you draw the histogram, the rectangles or the boxes accordingly. Then you arrive at the histogram with relative frequencies. So this is the first graph you see at the bottom of this slide is the relative frequency histogram for male participants. Then you can also draw the frequency polygon using the data and using the relative frequency values you calculated. So similarly, you have the classes from 0 to 20 and you mark the midpoints and you can draw the frequency polygon for male students. And similarly, for the distribution of female students' marks, you can draw the relative frequency histogram as well as the frequency polygon. So in order to do that, you have to calculate the relative frequencies at each populations. Now we introduced another important concept, which is cumulative frequency. So this is useful in conveying information about frequency observations that are below or above a specified level of the response variable. So cumulative, you add up, summing up the consecutive frequencies. So we can identify two parts. So when the interest of the investigator focuses on the number of cases below a specific value, then that specific value represents the upper limit of the class interval. So this is also known as a less than cumulative frequency distribution. On the other hand, when the interest lies finding the number of cases above a specific value, then this value is taken as the lower limit of the specified class interval. So this is also known as more than cumulative frequency distribution. Let's take an example. So here in this table, you are given a summary of ages of employees in an office. So you have 6 classes, 15 to 25, 25 to 35, and so on. And the frequency for each class is given. So you are required to construct the table with less than and more than cumulative frequencies. So first, we attempt the less than cumulative frequency distribution. So you start from the class number 1, which is 5, and you go for the class number 2, in which the frequency is 3, and you add 5 to 3 to get the cumulative frequency as 8. So which means that there are 5 persons less than 25 and 8 persons less than 35. Moving on, 15 persons less than 45, and so on. So you see the less than relationship. Okay, so you add up the values, add up the frequency values from the smaller side. So you start from class number 1, add the value from class number 2, add the value from class number 3, and so on. So you get the cumulative frequencies 5, 8, 15, 20, 23, and 30. So similarly, you can also derive the greater than cumulative frequency distribution. So in this time, you start from the bottom, right? So you start from 7, 7 plus 3, 10, 10 plus 5, 15, 15 plus 7, 22, and so on. So in this greater than cumulative frequency distribution, 30% are older than 15. 25% are older than 25. 22% are older than 35, and so on. So you get the two sides. Either it's less than relationship or greater than relationship. So using the cumulative frequency, you can represent these two ends. That brings us to the end of this lesson on tabular representation of data. In the next lesson, we will discuss about descriptive statistics. Thank you.